We're given two actually two sums. Part A is the sum of the following terms: 1 plus 3 plus 5 plus 7 plus 9, and part B is 2 plus 4 plus 6 plus 8 plus 10 plus 12. They want us to take each one of those and find summation notation using the index I and starting with the index 1. So what they're asking us to do in part A, is take a sum of index I starting with the number 1, ending at some unknown number, question mark, of the terms a sub I. So the basic outline is that the bottom index has to start at 1. We have to figure out where it stops on the top, and we have to figure out what the term a sub I, the ith term. So the top ending index is what we're looking for, and the term a sub I. Well, to get the top ending index, just count the number of terms in the list they gave us. There are 5 terms being added in that list of 1 plus 3 plus 5 plus 7 plus 9. So we'll end our index at 5. We're going to be doing a sum from I equal 1 to the number 5. That accounts for each one of those terms. Next, we have to find a formula for the ith term. To find a sub I, we want to list the indices. The index, which we call I, will first be equal to 1 for the first term, and then 2 for the second, 3 for the third, 4 for the fourth, and 5 for the fifth. That's the value of I for each of these terms. So the ith term, a sub I, is equal to, well, the first one is going to be equal to 1, plus the second one is 3, plus the next one is 5, that's the third term, plus the number 7 plus the number 9. So I've lined up the terms, the ith term, under the appropriate index, I. So for the first term, we have to figure out a way to express the number 1 with a formula that depends upon the index. And in that first position, that's the index 1. In the second position, it's the index 2. For the third position, it's the index 3. Now, this is hard, and it's difficult to explain. I just have to meditate on these for a while and think about how can I write each one of these with the same formula, but using a different index each time. And they're all related. The a sub i's have to be related to their index I. So for the first one, whose value is 1, I thought, well, 2 times the index 1 is minus 1. What does that equal? 2 times 1 is 2, minus 1 is equal to 1. So that works. And the thing in parentheses is what I'm claiming will be our index. Let's see if it works for the next one. 2 times the index minus 1. We had, for this value 3, we have 2 times the index 2. See, the index is 2 above, minus 1. What's the value of that? 2 times 2 is 4, minus 1 is 3. Yes, it worked. Let's see if 2 times the index minus 1 works for the I equal 3 term. Let's see, in other words, if the value is 5. 2 times the index 3, that's 6, minus 1 is 5. Yes, it works. How about 2 times 4 minus 1? That's 8, minus 1 is 7. And 2 times 5 minus 1, that's 10 minus 1 is 9. They all fit this formula, 2 times the index minus 1. So from that pattern, we draw the following conclusion. A sub I, the ith term, is 2 times the index I minus 1. You can write that as 2I minus 1. Conclusion, the sum that they gave us, 1 plus 3 plus 5 plus 7 plus 9, in summation form starting with 1, is equal to sum I equal 1 to 5, and 5 was something we found by counting the terms of the ith term 2 times I minus 1. Nice. Takes a while to get it. Let's do the next one. 2 plus 4 plus 6 plus 8 plus 10 plus 12. Count how many terms. There are 1, 2, 3, 4, 5. There are 6 terms in this sum. So our index is going to start with I equals 1 because they asked us to start with 1, and it's going to end at 6 to cover all of our 6 terms. Now comes the hard part, the a sub ith term. A sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5 plus a sub 6 is equal to the numbers they gave us, 2 plus 4 plus 6 plus 8 plus 10 plus 12. Okay, now try to come up with a formula to describe the values that we just listed for each term using its index only. Write the term, write it out in terms of the index I. So the number 2 is the first one. How about 2 times the index 1, where I is equal to 1? That equals 2. 2 times 2, that equals 4. 2 times 3 is 6. See, I'm multiplying 2 times the index, and each time I'm getting the value above. So we stumbled upon this formula where the indices are the numbers in the parenthesis. 2 times I. Index I equals 1, I equals 2, 3, 4, 5, and 6. And each one of those formulas work. So we draw a general conclusion that the ith term, A sub I, is equal to 2 times the index I. And our conclusion is the sum that they gave us is equal to the sum I equal 1 to 6. They told us to start with 1. 1 to 6 of the term 2 times I. It just takes a lot of the comparison. You're not going to get it right on the first try. Just keep messing with it until you get a formula that works for all of your terms in the sequence, in the sum.